All right, so here's a review of the first part of our book, part 1, which was chapters 1 through 6. Dealt with describing data, the normal model. The first thing we looked at was the W's. Who's being studied? What are you studying about that who? When was the study conducted? Where was the study conducted? Why? And how did they gather the data? Now the point of this chapter was to get us accustomed with looking at a word problem and determining what the word problem is about, so that later on we can write our answers in context, we can interpret our confidence intervals. We have to know the W's in order to do all of that stuff. We looked at the two different types of variables, categorical and quantitative. Categorical variables were described by categories like gender, blood type, breed of animal, voting preference, area code. Even though area code is a number, it's a category. It can't be added or subtracted. Same with zip code. And the other one was quantitative. Quantitative was data we can describe numerically. We can average quantitative variables. We can add them. We can subtract them. We can do statistics with those. Those were the variables that we used most through the chapter or through the class. So we learned how to describe distributions, the different types of graphs. We talked about our shape, our center, our spread, and outliers. We called that our socks. When we described shape, we talked about either symmetric. Symmetric looks like this. Skewed, this is skewed to the right because our tail is off to the right. Or skewed to the left, the tail is off to the left. Outliers are values that don't seem to fit the rest of the data. When we have the data, we can calculate the outliers using our outlier rules. That was your Q1 minus 1.5 times your IQR. And your IQR, remember, is Q3 minus Q1. Expect at least one problem that asks you in some way, shape, or form to calculate your outliers. The center, if you don't have the data and you're just looking at a graph, you're estimating the center of the data. But if you have the data, that's calculating either the mean or the median. Remember, the mean is the average and the center is the middle number. And then spread, if you have the data, once again, you're going to calculate standard deviation. So if the data is symmetrical, you're going to use the mean and your standard deviation. And if the data is skewed, you want to use the median and the IQR to describe that data. Remember that if you are comparing two distributions, you need to use comparative words, like the mean for this distribution is higher than the mean for that one. We talked about making box plots. In order to make box plots, you had to do your 5-number summary. Your 5-number summary was your minimum, your Q1, your Q3, your median, and your max. And a box plot goes in that order. You have your minimum, and then you connect it to your Q1, and then you have the box that ends with your Q3, and your median is the middle line. And then you connect the line to your maximum, and if you have outliers, you put them out here. Remember your percentages based on that each part of your box plot is 25% of your data. So this is 25%, this is 25%, this one is 25%, and from the Q3 to the max is 25%. So you can talk about that when you are asked to describe and talk about compared distributions. Then we talked about the 68, 95, 99.7 rule, which might be referred to as the empirical rule. It describes normal distributions. A normal distribution has the mean in the middle, 1 sigma, 2 sigmas, and 3 sigmas, and -1 sigma, -2 sigma, and -3 sigma. And we say that 68, it's approximately 68% of the data lies between the first standard deviations. Approximately 95% of the data lies within 2 standard deviations of the mean. And approximately 99.7% of the data lies within 3 standard deviations of the mean. When you're asked to describe the distribution, the normal model, you can talk about those percentages. We use this to draw pictures in our hypothesis test to get an idea of what we were actually calculating. The last thing we talked about was the normal model and calculating z-scores and finding probabilities based on that normal model. In order to use the normal model, our data has to be symmetric, somewhat symmetric, and unimodal. It doesn't apply to skewed data, data with really bad outliers, or data that is bimodal. Calculating our z-score, when you're told that something is normal and you're asked to find that calculation, it might say something like the mean fuel efficiency, it's a problem we did, is 24 miles per gallon with a standard deviation of 6 miles per gallon. What's the probability that a car gets less than 17 miles per hour? In order to do that, your x in here is the 17 minus the mean, 24, divided by 6. That's your z-score. Remember, your z-score describes how many standard deviations you are from the mean. And so that is negative 7/6. And to find the probability, we put that into normal CDF. It's normal CDF. And I want to know less than, so it's negative 99, negative 7/6. And that gives me your percentage. I don't have my calculator with me right now. So you can plug that into your calculator. Remember, normal CDF is in the second VARs button to find normal CDF. And we never use PDF, always CDF. Then the other thing we did is we went backwards. We used the inverse of the normal model. What if we wanted to know what the worst 25% of cars gas mileage? If I want to know the worst 25%, I'm going to do inverse norm. That's also in second VARs, 0.25. And I believe that's like negative 0.6745. You can correct that because, again, I don't have my calculator. And then we use that, negative 0.6745, solving for x minus 24 over 6, and you can do the algebra on that. One thing we need to remember about this inverse norm is that inverse norm only gives us the lower percentages. So if I want the best 25%, I have to do inverse norm 0.75 if you have the older calculator. If you have the newer calculator, I believe it does allow you to do an upper percentile. We'll have to look at that together. And the last thing we talked about was data shifting. How does changing the data, adding something to each value, change the statistics? What we know is that measures of position are considered minimum, Q1, median, Q3, the maximum, and the mean. Those are all measures of position. The actual numbers that are on your box plot, those will translate. You can add a constant to them and they will dilate. You can multiply them by a constant. But measures of spread, the IQR and the range and the standard deviation, they only dilate. And that's because if you're moving your Q1 and your Q3 up 5, you're not actually changing. So if Q1 is 3 and Q3 is 8, and we add 5 to those and we move them to 8 and 13, my IQR didn't change. It's still 5 because I haven't made it more spread out. But if I multiply them by 2, and my Q1 becomes 6, and my Q3 becomes 16, now my IQR is 10, so it has gotten bigger. All right, guys, I hope this helps a little bit. Maybe we can cut off some time in class and get to some more problems. So there's your part 1 review.